Chapter 23 is about mining. The case study is interesting because as a global citizen, you should be aware of sometimes how our resource use can trigger great hardship for other people. And so I encourage you to read the case study about what has happened in Africa mining the precious metals for our cell phones, just to be aware of what's going on in the world as a global citizen. And you can see there's also been some solutions, some things that people have done to try and help. The first section is really about minerals and how we use minerals that we mine for all over our life. You can see the picture, all kinds of things that we use every day, minerals that were mined out of the ground. How do scientists find ore minerals? Well, they find them through seismic studies, through rock cores, magnetic fields, and the chemical analysis of water. And all of those things can help scientists pinpoint where the minerals are to mine for. On the next page, know these definitions. So we know what a metal is, what ore is, smelting. So we can take the ore and get the mineral out through the smelting process. And one of the waste products from mining are tailings, which are the ore left over after the metals have been extracted, and it's a waste product. And then know what a surface impoundment is, also from this page. Turning the page, know this figure and caption. Well, first we need to know about different kinds of mining methods. So this figure and caption shows you the difference between surface and subsurface mining. One type of surface mining up here is strip mining, where we basically just strip the hillside down by bit by bit by bit. And then underground mining we call sub means under, so subsurface mining, and that's underground. That's the traditional way of mining. Not always traditional. I mean, we've done strip mining since the gold rush days even. But when we think of mining, we think of underground, but it's not always underground, especially nowadays. A lot is above ground. So know these definitions here. Strip mining, what overburden is. So it's the ground that's been removed off to the side. Acid drainage comes when things like coal seams are exposed to air, that when they haven't been exposed to air before, and they create sulfuric acid. Leachate is different. So leachate in the last chapter was anaerobic, but in this chapter, the leachate from mining is from aerobic reactions with inorganic, so non-living things is produced. So that's water waste from mining. Okay, so subsurface mining on 640 is the most dangerous type of mining because of cave-ins. It's the least environmentally harmful. Now, it still has harm, but it's the least environmentally harmful, and also miners can get black lung disease from mining for many years underground. Above it is a picture of acid mine drainage, and so it has this color due to the iron from the drainage settling out. You see this very common with mines. Here's a giant pit mine. We actually have one not too far away from us, about an hour and a half north into the desert in a town called Boron. You can go and visit. They have a visitor center and an overlook, and you can see this giant pit mine out there where near us they mine for borax, actually. So that's an open pit mine. There's also placer mining, which in California history, it's what, panning for gold kind of a thing is placer mining. And a quarry is actually part of open pit. So the pits are called quarries when they extract certain things like granite and marble and slate. And then mountaintop removal is removing the entire mountain, and they do this in Appalachia, the top of the mountain, to get the coal out. It's so damaging. How do you fix that when you're done? It's pretty crazy. So you can see here at the top, they have removed the top of the mountain to get the coal. So if you lived in other parts of the country, not just West Virginia, but I've seen these go by in Montana and Colorado, and it's full of coal, and you would see coal going by if you lived in a lot of other states. And so this mountaintop removal, what do you do with all this soil? And so a lot of times with storms, erode it into people's neighborhoods and homes and property. It's pretty terrible. Here's the problems with mountaintop removal. Make sure you know a lot of those. We haven't had an FRQ yet on mountaintop removal, but we expect it to be coming anytime soon. All right, so know the definition of reclamation. And so reclamation is returning the land to as an original state as you can possibly get after the mine is closed. That's by law. SMRCRA is the law specifically for coal reclamation. So the Surface Mining Control and Reclamation Act refers to coal mining and reclamation. But people are saying, well, how do you reclaim a mountaintop when it's been removed? That's a very good question. And then you need to know the general mining law. Now, we studied this in an earlier chapter, but basically it's a law that has not been repealed by Congress, so it's still in effect. And it basically says that in certain areas, when these claims were taken over a century ago, that you didn't have to reclaim the land. And so some people have inherited these claims in various places, and so they can mine without reclamation. And so that's a kind of a terrible law that's still around. Congress can repeal laws, and it does. Like the Homestead Act was repealed a long time ago, but that one has not been repealed, which is not great. Okay, you also need to know what unclose is. Now, unclose is not in your book in this version, but it's basically an international treaty regulating ocean mining. And so basically it lays out which country has rights to certain pieces of the ocean. So how do we mine in the ocean? There's actually a show on Discovery Channel about people mining for gold by dredging up in Alaska. So they take these big suckers and they suck up gold from the bottom of the ocean. It's very dangerous work. And it's called dredging. Well, as you're sucking up gold, and then you're sucking up the bottom of the ocean, and then in your ship, you're kind of panning for the gold. You're sucking up a lot of marine life. You're ruining the benthic community. So dredging for minerals is not good for the ocean environment, the bottom environment. All right, so here's some environmental impacts of surface mining. Okay, so first, huge amounts of habitat destruction, really high rates of erosion from all that soil that is now loose and removed, sulfuric acid in the streams from acid mine drainage, toxic air emissions. Gold mining, they use cyanide to get the gold out of the ore, and so some places have had cyanide poisoning, like the cyanide runs into a lake and kills all the fish. Cyanide is a poison. Some mining can break pipes and sewer lines, depending on where you are. So an AP type question is, what is the most environmentally harmful? Well, you would say slag and tailings, harmful for water, sorry. Slag, which is the toxic heavy metals coming from mining, and the tailings, which is the leftover ore after the minerals have been stripped, cause huge amounts of water contamination from mining. And you need to know what happened in Colorado last summer in the Animas River near Durango, Colorado. 3 million gallons of toxic mine water was spilled into the river during an EPA cleanup of an old silver mine. So the silver mine closed in 1920, and the EPA was cleaning it up as a Superfund site, and one of their containment ponds broke and went down streams and creeks into this river, and the river turned yellow with toxins. It was pretty gross. And that, I believe, is all you need to know for this chapter, and I'm right, that's it.